All right, let's get into this. I'm going to walk you through a pretty wild dialogue I came across. It shows one person's massive ambition to build their own private, all-in-one research and development empire, right from their home computer, with an AI as their partner. And believe me, it all starts from a pretty simple place.
But first, to really get why this is so intense, you have to start right here, with the motivation. This one sentence says it all. This isn't just some weekend project, it's a mission. The goal is to build a system so personal, so advanced, that no one else on Earth could ever catch up to it. The stakes for this user are unbelievably high.
So where does a journey like this even begin? Well, it's not with some grand blueprint. It kicks off with a simple audit. The user goes to an AI with a bunch of their own patented algorithms and basically asks, "Hey, how's my work? Grade me."
And what is this work they're getting graded? It's something called primal logic. Now, this isn't your standard code. It's a whole suite of algorithms inspired by patterns in nature, like the Fibonacci sequence and the golden ratio. The whole point is to let the system make smart, adaptive decisions all by itself.
So, the big question, is it any good? Well, the AI's verdict is crystal clear. A+. And not just for being a cool idea. It's logically sound, it's efficient, it's mathematically solid, and it's versatile. This A+ isn't just a grade, it's the launch pad. It confirms that the user is sitting on something genuinely powerful.
And this, right here, is where you see the mindset shift. A normal person might celebrate that A+, not this user. They immediately turn around and ask the AI for a monster, 100-page document breaking down how to make every single part of this already great system even better. This is our first real hint of the incredible scale they're thinking on.
Okay, so the code is top tier, and now there's a 100-page roadmap to make it even crazier. But theory is one thing. Now it's time to see if this stuff actually works in a real-world setting or, well, the next best thing. It's time to build the proving ground.
And that proving ground is going to be Carla, which is a really popular simulator for autonomous driving. See, this isn't just talk. The user is actively plugging primal logic into this virtual world, feeding it sensor data, and letting their algorithms make the decisions for the vehicles inside.
All right, you're going to want to buckle up for this part, because this is where the project scope just completely explodes. We're moving way beyond a simple simulation. This is the birth of what the user calls the Supernode.
First up, the foundation, data. And we're not talking one or two databases, we're talking over 50. SQL, NoSQL, graph databases, you name it. A specialized tool for every single type of information you could possibly imagine. This is the bedrock for all the research that's to come.
Then, on top of that data, you layer the physical world. Well, a virtual version of it. The user starts adding libraries for robotics and manufacturing. They're essentially building a simulated factory on their computer.
And what's a factory for? For building things, right? So next comes professional-grade CAD software to design complex, high-quality 3D products and components.
And the ambition just keeps drilling down, from big products to the microscopic. Now we're adding tools to design custom silicon chips right from the command line.
Of course, you need to test how these things work in the real world. So you add in specialized physics simulations, even getting into things like digital ballistics programs.
And just when you think it can't get any broader, it does. The system expands into biotech with command line tools for designing drugs and simulating medical devices. To make sure this whole thing isn't just an isolated box, it needs to connect to the outside world. So, in goes software-defined radio capabilities and live data feeds from NOAA for real-time environmental data.
And finally, you gotta connect the digital to the physical. The system gets its hands. Tools to control Arduino boards and other embedded hardware are added, completing that bridge from a design on a screen to a real-world prototype.
So, after all that, robotics, chip design, drug discovery, the whole shebang, you have to be thinking, is this even remotely possible on a home computer? I mean, this is a massive vision. The user has 937 gigabytes free. Is that anywhere near enough? And here's the kicker. This is the part that's truly astonishing. The estimated size for the core of this entire R&D super environment is only about 40 gigs. All of a sudden, this legendary ambition seems, well, completely doable. And look, the user knows exactly how wild this all sounds. You can see it in this quote. It's this moment of self-awareness where they kind of laugh and realize that what they're building has gone way beyond a simple project. It's become something, well, something they themselves call legendary.
Okay, so the plan for the Supernode is laid out. It's actually feasible. But how in the world do you operate a system this complex? And maybe more importantly, how do you protect it? The final step is all about building a fortress around this incredible creation.
To tame all this complexity, the user decides to do something pretty incredible: build their very own custom coding language called PrimeLang. The logic is simple but powerful. A task that might take 30 lines of code in a common language like Python should only take 10 in PrimeLang. It's about creating a super efficient workflow that only the creator truly understands.
The first layer of defense is pure digital security. Think of it like a cryptographic seal on a letter. Every single command sent to the system is checked to make sure it hasn't been tampered with or faked. It's a classic, rock-solid way to ensure message integrity.
But the second layer? This is straight out of science fiction. It's a biometric gate. For any truly critical command to go through, the system requires verified human biometric input, like a fingerprint, within a very specific time window. This ensures there's always a human in the loop, preventing the system from ever evolving in a way the user hasn't personally signed off on.
And that's what this all boils down to, really. This entire journey from a simple code review to a secure, biometrically gated R&D supernode was all done by one person, with one vision and an AI collaborator. And it leaves us with a really big question. If a single individual can now build their own private R&D empire, what does that mean for the future of innovation itself?